more than one feature column, or you can say the more than one independent variable. Like we are not having the equation as y equals to mx plus c. Instead, we are having x1, x2, x3, and like till xn. So what we'll be doing in that case? So let's look at the data set first, then we'll understand better. Like this 50 startups data set we are using. Now in this data set, first column is the R&D spend, the second column is the administration, the third column is the marketing spend, and fourth is the state. Now this time I have taken a data set which is little bit challenging than previous one, because here we are also having the categorical variable. Now the state is a categorical variable. You are not seeing any numbers here. So you have to basically encode this data first in order to fit in a machine learning model. And the profit value we have to calculate. We will train our model on this complete data, not complete basically. We'll be training this data on like this model on in 80% data. Let's take 40 data points to train our model. And then in the end, on 10 data points, we'll be evaluating our complete model. Now let's jump into our code, and firstly we'll pre-process the data, the conversion of this encoding, and like the conversion of this categorical variable into the numeric value, the encoding of our categorical variable basically. Then we'll be creating our training and testing set. Then we'll be implementing multiple linear regression model here. In multiple regression model, like in the linear regression, you have seen we have only one best fit line. Here you will have multiple best fit lines, and the equation is somewhat look like this. In the simple linear regression, we have equation of y equals to b1 x plus b naught. B naught is basically your intercept and this is your slope. And here basically you will have b1 x1, b2 x2 till bn x1, the number of features. Here the x value, n value is 4. Like in our data set, the n value is 4, like 4 feature columns we are having. So we will be having b1 x1, b2 x2, b3 x3, and b4 x4 plus b naught. B naught is your intercept. So the equation will somewhat look like this. Now let's jump into the code. Let's create another notebook of, let's name it as multiple linear regression. Now let's first of all import some of the libraries which we do in every video. First, importing libraries. Here also we'll be importing NumPy, pandas. Now let's import our dataset first. Importing dataset. Now let's create a variable of named as dataset pd.read csv. Here the dataset name was 50 startups dot csv, and again let's visualize this dataset first. Again we'll be sorry this scroll is not working, leave it. So this is our data set. So this 4 column will be using as our x variable, and this profit column is our y variable. So let's create that variable first. The dataset.ilog will be selecting complete row of 4 columns, excluding the last one. This we are doing in every right now. Dataset.ilog, and this sorry, I will be only using the last value. Oh sorry. Now let's visualize our x variable first. So here you can see our x variable, and let's visualize our y. So here you can see our y variable also. Now let's jump into encoding our categorical data. This is very important. Without that, the model will simply fail to train, because the model cannot accept any non-numeric values. It has to be numerical data only.